Yeah.
Okay, how are you?
Good, thanks. How are you?
I'm right, thanks. Let me share my screen. See my screen?
Yeah, I am.
Okay, last session we're working on this, right?
Yeah.
And have you tried this or not?
No.
Okay, so we said what? We said when we have a square roots, what are the approaches?
Just squaring it
There's one or
expressing it.
consider it as variable, right?
Yeah.
So last session we tried to do what? We said okay, x plus 1 minus, we raised to the power of 2, we said x plus 1 minus 2 over x. And it says x be the largest real number. Probably we will find some answers for these, and we should find the smallest one, the greatest one, right? So x plus 1 minus 2 over x plus this, 2 times this is x squared, and then 2 times this we took all things to the right hand side, minus x minus 1 plus 2 over x, then we raised to the power of 2. For this, we reached to this part, right? Okay.
Yeah.
Now we should multiply both sides by what to get rid of denominators?
Wait, could you say that again?
Your sound is too low.
Could you say that again?
I said I want to get rid of denominators, okay? I should multiply both sides by what to get rid of denominators?
X squared
Yes, so if you multiply by x squared, here I multiply x, so it will be 4 times what bracket what?
4 times x cubed.
No, I want to get rid of denominators, so I need 1x here, 1x here, okay?
Okay.
If you multiply this by x squared, still here we have over x.
Would not be equal to 4x squared minus 1. I mean x squared minus x.
No, minus 1
Uh,
times.
minus. Is it? Oh, yeah, yeah. Minus 1, x minus 1. Yeah.
What about right hand side?
Right hand side would be x cubed minus x squared minus x plus 2 squared.
Exactly. Now I want to simplify, okay?
Yeah.
So as you can see, we had 2 this part, 4, take the right hand side, 2 over x, we multiply by this. Here it is x minus 1, x minus 1, x plus 1, right?
Yeah.
Okay, the roots here are 1 and negative 1, right?
Yeah.
But here we can see the roots are not 1 and negative 1, because if you place 1 minus 1 minus 1 plus 2, it's not 0. If you place negative 1, it will be this, plus 1 plus 2, again not 0, right?
Yeah.
Okay, so here one way is to expand and see what happens, okay?
Yeah.
So try to expand and simplify this equation completely, okay?
To like make it equal to 0.
Exactly, x to the 6 plus this, simplify completely, okay? And then we try to find the roots, okay?
So I got like x to the 6 minus 2x to the 5
X to the
minus
6 minus 2, let me write. X to the 6 minus,
minus 2x to the 5
yes?
minus x to the 4 plus 2x cubed plus x squared.
Okay, let's check. Here, we can say this part is 4x cubed minus 4x squared minus 4x plus 4, right? Is equal to x to the 6 plus x to the 4 plus x squared plus 4 minus 2x to the 5 minus 2x to the 4 plus 4x cubed plus 4x cubed and minus 4x squared plus 4x. So we can cancel 4 and now. So if we write x to the 6 is okay. We don't have x to the 5. So x to the 4. X to the 4 minus 2x to the 4. Here, okay. So x to the 4 minus my. Let me see. Sorry, we have negative 2x to the 5. It's correct. Minus x to the 4 is correct. We've considered this one and this one. And at the end, we will check that we should consider all of them. For x cubed, it will be 4x cubed, negative 4x cubed, 4x cubed. This one x squared, 4x cubed. So we can cancel this 4x cubed. So these two 4x cubed. So isn't it 4x cubed? Let me check it again. You said minus x to the 4. Let me check it. 4x cubed here we have. And here x cubed. We have 4x cubed plus 4x cubed again. So let me see again. Do you agree this one? I said negative 2x to the 5. Negative 2x to the 4 plus 4x cubed. Then, sorry, here again. My mistake. 2x cubed. Then 4, then 4. Okay. So 2x cubed will be left here. For x squared, what do we have? Minus 4x squared plus x squared. Let me check it again. Negative 4x. Again here minus 4x. Okay. Yes, good job. Here I had some mistakes. Okay. Now we have this, right?
Yeah.
So then we can conclude what? Because this part is 0.
You can take out the x squared.
Yeah, so
Right.
x is what? X is 0, right? Or x to the 4 minus 2x cubed minus x squared plus 2x plus 1 is 0, right?
Yeah.
Okay, here can we factor from something? For example, look here, because we have 2. For example, minus x squared plus x plus 1. Then x to the 4 minus 2x cubed. I am thinking of something. Here, for example, if we write minus x cubed, then minus x squared, then, for example, again plus minus this. Okay, try to solve this one. Try to see can you solve this equation. Okay, try to see can you factorize. Okay. One hint.
Yeah.
Okay, we have a trick. It was useful also in BMO 1. That, what can we say? If you see the coefficients, they have a pattern. Can you tell me the pattern is what?
Like 1, 2, 1, 2,
No,
1.
no. Look, this is equal to this one. It is, let's see. X cubed. No. We don't have that pattern, right? But let me think. Here, but they are similar. For example, negative 2, 2, 1, 1, right? So let's see, can we do something related to this? If we divide, for example, let's check this approach. X squared, if we divide both sides by x squared, then what can we say?
Be x squared minus 2x minus 1 plus 2 over x plus 1 over x squared.
X squared minus 2x minus 1 plus 2 over x plus 1 over x squared, right?
Yeah.
And then here, can we consider a good thing or not? Here we cannot reach a good thing, right? Because they think so. Let's use another approach. Because the coefficients are not exactly equal. Here is negative. If it was, for example, negative 2, it was better. So let's consider this one. X cubed, x to the 4 minus x cubed minus x squared, right? Then what is left?
Then is x negative x cubed plus 2x plus 1.
Is 0. Now I want to have similar to this form. It starts from x to the 4. In next step, I want to start from x cubed. So I say negative x cubed minus x squared minus x. Then can you tell me what is left?
X squared plus 3x
No.
plus 1.
Careless mistake. Try again.
X minus x squared plus 1.
X squared, x squared. Look, this part should be
X
negative x squared. This part should be equal to this one. Negative x squared, then what?
plus x plus 1.
Exactly. Now, all these three terms, three brackets, are multiple of a common term. And the rest is not hard. Try the rest, okay?
X squared minus x minus 1 whole squared.
Okay, let's check. Here, if we factor, it will be x squared minus x minus 1 times x squared minus x times x squared minus x minus 1 minus x squared minus x minus 1. So x squared minus x minus 1 is equal to x squared minus x minus 1, 0, okay?
Okay.
And then we can say this. So let me tell you another approach to be able to factorize something like this. We have this term. So sometimes when you want to factorize, you try to find one root, okay? And when you see it's not possible, you say, okay, suppose, for example, it is x squared plus ax plus b, x squared plus cx plus d, okay?
Right.
Then coefficient of x cubed, if you consider, is what?
Should be like a plus c.
Exact, a plus. Which is what here?
Um, which is well, negative 1 times x plus negative 1.
Negative 2,
Negative
negative
3.
2, negative 2.
Yes.
Finished. X squared. Coefficient of x squared is what?
B plus D plus AC. No, plus A plus D.
No. Pay attention. B plus.
Yeah. B plus D plus AC.
Yes. Is equal to what?
Uh, -2 again.
No. We are considering coefficient of x squared.
-1, -1.
-1, because they should be equal. Coefficient of x will be what?
AD plus BD.
AD plus?
AD plus CD. Sorry, I mean CB.
Yes. CB or BC is equal to what?
2.
Constant term is what?
Just BD,
Which is equal to what?
which is equal to 1.
Yes. So which equation is better to start with?
A plus C is equal to -2.
So there are lots of answers, 1, -3, 2, -4, infinitely many answers to check, right? In integers, we want to find coefficient. So this one has infinitely many answers, so it is not so much good to check, right?
Yeah.
So which equation is better?
To check would probably be B plus D plus AC.
No, that one is also has lots of values. Last one, BD is 1. We can conclude. What about B and D?
They are equal and equal to 1
1
if they're
or
integer.
both of them are 1 or
Or B is equal to 1 over D or vice versa.
B and D are integers. Product is 1. One case is 1, 1. We have one more case. What is the other case?
Oh, -1, -1.
Exact. Okay. Now that B and D are 1, let's replace them. We want to check these two cases. Okay. For case 1, we say, okay, B and D 1, so A plus C -2. Second equation will be what when B and D are 1?
AC is equal to -3.
Exactly. AC is equal to -3. And is it possible this case? So let's write
No,
also last one. AD is A plus C is A plus C. That means BD, yes, A plus C is two contradiction, right? Now second case. A plus C is -2. What about second equation?
AC is equal to 1.
AC is equal to 1. What about last third equation?
-A minus B. I mean minus C is equal to 2.
Yes, or A plus C is equal to what?
2, -2.
Yeah, so satisfies first equation and third equation are same. So A and C, one example is what to satisfy these equations for A and C?
-1, both of them equal to.
Yes, so here we can say x squared. B and D are -1. Minus x minus 1, x squared minus x minus 1. We found coefficients, right?
Yeah.
So it was another approach. In HKIMO also it was useful in, I think, HKIMO 2022 for Hong Kong. So we found this. Now solve the rest of the problem. The problem says find maximum x and then find 2x minus 1 to the 4, okay? So we've reached to this part. Find the answer.
Right, okay.
Could I use calculus to do this?
No, you don't need. What do you mean by car? Because here quadratic formula apply and you find x. X is 0 or 2 roots of this quadratic equation. We have 3 roots. See which of them is greatest, then calculate 2x minus 1 to the 4, okay?
Oh yeah, because I was thinking it wasn't didn't have real roots because I was thinking of x squared plus x plus
Ah,
1.
no, it has real roots. If we didn't have real roots, x will be 0, right? X should be 0.
Yeah.
Okay, try.
Could you go back to the question?
Okay, sure.
Is the answer 25?
Exactly, good job. So let's calculate this part together. Here the roots are what? This root 2, right?
Yeah.
So maximum x is 1 plus root 5 over 2, right? So in
Yeah.
this case, 2x minus 1 is root 5. So 2x minus 1 to the 4 is 25, as you said, right?
Yeah.
Okay, this was a good problem, really good problem of this factorizing. It was the first time that we factorized like this, right? Have you factorized like this before or not?
No, I don't think.
Okay, it is for the case when, for example, degree is 4 and sometimes degree 5, and each term, the degree of each term is not 1. So we solve problem 16 here. Now let's try next ones.